So now we are going to be solving systems of equations using 3x3 matrices and 3x3 inverses. So you guys learned in the previous video how to find an inverse of a 2x2 matrix, which you have to know by hand. But for 3x3, since they are so complicated, we're just going to be using our calculators to find the inverses and then eventually to solve for the variables that we have. So I have this example here. I have a set of 3 equations. And just like the 2x2s when I was solving a system of equations, I'm going to write out a matrix equation. So I'm going to have a 3x3 matrix here because I have 3 equations and 3 variables, x, y, and z. My column vector is just the variables. And then the right side of my equations. And remember, this matrix up here is going to be 3x3 this time, and that's just going to be our coefficients, just like the last video, not any different. So that's 1, 2, 1, because there's 1's in front of the x, 1 in front of the z. I have 3, -4, 5 for the second equation. And for the last one, I have -2, -8, and -3. So just the coefficients in this first matrix. Now, if you remember from the last video, in order to solve this, I multiplied by the inverse of this matrix on the left side on both sides of the equation. So we need to find the inverse of this 3x3 matrix. So I'm just going to label it as B. So we need to find B to the -1. And like I said in the beginning of the video, we're going to be using the calculator to find our inverse of this 3x3 because it's very complicated to do by hand. So I'll let you guys know how to do that on your graphing calculator. And I wrote out the steps here. Make sure you write this down in your notes. So first, I'm going to go to second x to the -1, which is my matrix option right here. I'm going to go over to edit and click enter. I'm going to enter it as matrix A, although we have it as B here, so just keep that in mind. So I have to input the dimensions, which is 3x3, so 3x3. And I have already entered 1, 2, 1, 3, -4, 5, -2, -8, -3 into here. So enter those in. You know how to do that. Just click the number and then enter. And when you've entered it all in, you have to exit out, which is second mode. So now I have a blank screen. I go back to second x to the -1 and I click on my matrix A. I've selected it. And then I click x to the -1 button, just that button, and that'll give me my A inverse, which is what we're trying to find. I click enter. And you'll see that you'll have to scroll to see the numbers. And then the one problem is that we don't want decimals. We want nice clean fractions. So we're going to go to math, enter, enter. So math, enter, enter to get fractions, and you still have to scroll, but it's much easier on the eyes when we have fractions. So I'm going to write down the inverse matrix that I got right here. So I got 26/9, -1/9, 7/9, -1/18, -1/18, 1/9. So that's our inverse of our 3x3 matrix right here, and I found that using the calculator with these steps. You can use the calculator to find an inverse of a 2x2 matrix, but you need to know it by hand, and you can learn that in that first video that I have posted. So we found our inverse, and now we use multiplying on the left side I'll rewrite it, don't worry, but this is the idea. I'm multiplying this inverse on the left side on both sides. So I'm going to go down here to do my math work, and I'm going to rewrite. So I have 26/9, -1/9, 7/9, -1/18, -1/18. multiplied by b, which is 1, 2, 1. My column vector of variables equals the inverse again because I'm multiplying on the left side. So I'm just rewriting it by multiplying on the left side. So now if you remember from the first video, since this matrix is the inverse of this one, they just give me the identity, which is the equivalent of 1. So now I have x, y, and z on my own, which is my goal. I want to solve for x, y, and z is equal to all this right here, and we are going to use the calculator to do our math for this matrix multiplication. So I have this first row times the column, so 26 over 9 times 0 is just 0. I have negative 1 over 9 times that negative 11 plus 7 over 9 times 1. Second row times the column, negative 1 over 18 times 0, 0. So I just have these two left over. Negative 1 over 18 times negative 11 plus negative 1 over 9 times 1. And I have the last row, so that 0 cancels out the negative. So then I have the last row times this column, negative 16 over 9 times 0 is just 0. So I have 2 over 9 times negative 11. And then negative 5 over 9 times 1. So just simple math right here. And then I plugged it into my calculator and I got 2, 1/2, and negative 3. So x equals 2, y equals 1/2, and z equals negative 3. So just to recap, I have my system of equations here. I set up a matrix equation using the coefficients, the variables, and then the answer on the right side. Okay, and to solve this, just like my 2x2s, I have to find the inverse of this matrix, and I did that using my calculator with these steps, my graphing calculator. So I found that to be this is my inverse. And then just like my 2x2s, I multiply on the left side on both sides so that these two cancel out and make the identity matrix. So I just have x, y, and z because I'm trying to solve for them. And then I just do this math over here to get exactly what x, y, and z equal. So that's it for solving systems of equations using the inverse of a 3x3 matrix.